And I'm going to share my screen. All right, so today we are going to finish chapter 3, and we are going to look at arguments. So everything we've talked about so far in chapter 3, we talked about logical statements and truth tables. And I think I actually said in class one day, a week ago or so, about arguments. I said, no, I got to wait to talk about arguments till later. And we're going to use what we've talked about with logical statements and truth tables to determine if an argument is valid or invalid. So we're going to be looking at logical arguments. Now, the conclusion of a logical argument may or may not be true, which is kind of weird, but the argument can still be valid. So let's talk about that. So we're going to talk about the validity of a symbolic argument, and we're going to check the validity of an argument either using the standard arguments. There are arguments that are standard that we've been using for thousands of years, or you can use truth tables. And then if we know the premises of an argument, we can use a standard argument to determine a conclusion to that argument. All right, so let's define what an argument is. So an argument is a set of premises and a conclusion. So we say this, and then we have a conclusion from our premises. So let's look at these logical statements. So we have the conditional. If we go to the Bahamas, then we go snorkeling. So the first sentence we have there is the conditional statement, if then. With the two statements, we go to the Bahamas, we go snorkeling. The second sentence is just the logical statement, we go to the Bahamas. So we can call these two things premises. So the first premise would be, if we go to the Bahamas, then we go snorkeling. And the second premise would be, we go to the Bahamas. So what would the conclusion be? Well, if the first premise is, if we go to the Bahamas, then we go snorkeling. If we go to the Bahamas, then the conclusion of this argument should be that we go snorkeling. So the first premise we can say is, if we go to the Bahamas, then we go snorkeling. The second premise is that we go to the Bahamas. So the conclusion would be, if we go to the Bahamas, then we go snorkeling. We go to the Bahamas, then the conclusion would be that we will be going snorkeling. So this is the form of a logical argument, where we have a premise, and then we have a conclusion. And you may have multiple premises. You can have 2 or 3 or 4. You can have a bunch of them. And then you have one conclusion. So that is the form of a logical argument: premises and conclusion. So a symbolic argument consists of a set of premises and a conclusion. It is called a symbolic argument because we generally write it in symbolic form to determine its validity. So an argument is valid when its conclusion necessarily follows from a given set of premises. So in the previous argument that we looked at, that argument is actually valid because the conclusion we drew was from the set of premises. So that is a valid argument because the conclusion didn't necessarily follow from premise 1 and premise 2. If it's not valid, then it's invalid or a fallacy. An argument is invalid or a fallacy when its conclusion does not necessarily follow from the given set of premises. Okay, so the first valid argument type we look at is called the law of detachment. So this is written symbolically as follows. The first premise is in the terms of a conditional, if P then Q, where P and Q are logical statements. The second premise is in the form of the statement P. So the first premise is if P then Q. The second premise is the statement P, and our conclusion will be Q. So the way this is read is premise 1 is if P then Q. Premise 2 is P. The conclusion is Q. So we say if P then Q and P therefore Q. So the ... there, that little ... is read therefore. And I can change my screen here so I can actually write here. Okay, so we have our first premise in the law of detachment. Our first premise is in the form of a conditional. If P then Q. Our second premise is just a statement, and it's going to be the first statement. And our conclusion is going to be our second statement. So this is called the law of detachment. And the way we write this symbolically is premise 1 and premise 2, then conclusion. So it's if premise 1 and premise 2, then conclusion. So the way we write this symbolically is if premise 1 and premise 2, then conclusion, or if P then Q and P. So we got an if P then Q and P then Q. So this law of detachment written symbolically is what we have at the bottom of this slide. Okay, let's construct a truth table for this symbolic argument. If P then Q and P then Q. Let's do a truth table for this. Okay, so the truth table will be as follows. We have 4 cases, P and Q. So P can be true, true, false, false. Q can be true, false, true, false. So the first thing we want to do is inside these brackets. So we want to first do the conditional, if P then Q. The conditional if P then Q is only false if the antecedent P is true and the consequent Q is false. So it's only going to be false for case 2. Next, we want to rewrite P. So we have a column which we numbered 2 as column P. And then we're going to do the connective, the conjunction. So we're going to do the conjunction for column 1 and column 2. That will be column 3. The conjunction is true only if both statements are true. So it's only going to be true for case 1. That's the only place where the the conditional is true, and P is true. So it's only true for case 1. All right. So now we have this part of our logical statement done. So now we want to do a conditional between that, the conjunction, and Q. So we rewrite Q, that is column 4. And now we are going to look at column 3 and column 4, and we're going to do the conditional. And the conditional is only false if the consequent is true and if the antecedent is true and the consequent is false. If the first one is true and the second one's false, then it's false. And none of those are the case here. Each one of these, the consequent in the first case is true and the antecedent is true. So the conditional is true. All the rest of these, the antecedent is false, and then the consequent is either true or false. So for that conditional, column 5, then the entire column is true. So our entire answer column is true. That makes this argument valid. So if you create the argument symbolically, where you have premise 1 and premise 2, then conclusion. So if premise 1 and premise 2, then conclusion. If the entire answer column is true, then that argument is considered valid. So you're going to create the symbolic argument from your premises and conclusion. Check the truth table. If the answer column is entirely true, then that argument is valid. So the law of detachment is a valid argument. So the original argument we looked at, if we go to the Bahamas, then we go snorkeling, we go to the Bahamas. So the conclusion is we go snorkeling. This is a valid argument because it is the law of detachment. So our first premise is if P, then Q. Our second premise is the statement P. Our conclusion is Q. This is a valid argument. This is the law of detachment. Okay, let's check this argument. And let's determine if it's valid or invalid. So my first premise is if Canada is north of the United States, then Alaska is in Mexico. Our second premise, so here's our first, helps if you have a pen. And our second premise is Canada is north of the United States. And our conclusion is Alaska is in Mexico. So I'm going to let my two statements be Canada is north of the United States. My second statement is going to be Alaska is in Mexico. So my first premise in symbolic form would be if Canada is north of the United States, then Alaska is in Mexico. So that is the conditional if C, then A. If C, then A. My second premise is Canada is north of the United States. So that is C. So according to the law of detachment, if my first premise is if C, then A, and my second premise is the first statement, statement C, my conclusion must be A. So for it to be a valid argument, my conclusion needs to be that Alaska is in Mexico, the second statement, which it is. So this is a valid argument because it follows the law of detachment. If C, then A, and C, then A. Now, is this a true statement? The answer is no. Alaska is not in Mexico. So my conclusion is not true. That doesn't make the argument invalid. So you can have valid arguments whose conclusions are not true. And gosh, this happens just about every day in politics. So again, you can have an argument that's valid. It follows the laws of logic, but the conclusion isn't true at all. So this is an example of a valid argument whose conclusion is not true. All right, how do you determine whether or not an argument is valid or not? So first thing you're going to do is take your argument, your premises, and your conclusion and write it in symbolic form. So you're going to join your two premises or three premises, however many you have, using the connective conjunction. So you're going to use and. Then you're going to write your conclusion as a conditional. So it's going to be if your premises all joined by ands, then your conclusion. That will be your symbolic argument. Then you're going to first compare the form of the argument with the forms that we know to be either valid or invalid. And we're going to look at the forms that we know here in just a second. If it doesn't fit any of the normal forms of valid or invalid arguments, then you're going to have to create a truth table. So if the argument contains two premises, write a conditional statement in the form of premise 1 and premise 2. If premise 1 and premise 2, then the conclusion, and then construct a truth table for that statement. So if it doesn't fit any of the forms that we know of, then you're going to create a truth table using the premises and the conclusion. If the answer column of the truth table is all truths, that is a tautology, and the argument is valid. If the answer column of the truth table does not have all truths, then the argument is invalid. Okay, so let's see if we can't do this. So let's determine if this argument is valid or invalid. So my first premise is, if you have enough reward points, then you get a free flight. My second premise is, you do not get a free flight. My conclusion is, you do not have enough reward points. So I am going to let this be my first premise, which it is. This is my second premise, which it is. And then my conclusion is, you do not have enough reward points. So I'm going to first create my logical statements. So I have, if you have enough reward points. So I'm going to let you have enough reward points be my statement P. So that is going to be my logical statement P. And I'm going to let you get a free flight be my logical statement Q. That is going to be Q. Okay, so what we have here is the first premise is a conditional. If you have enough reward points, you get a free flight. So that's going to be if P, then Q. But premise 2 has a negation in it right here. It has a not. So we are going to negate Q. And then we're going to look at the conclusion. So let's see if we can't write this argument in symbolic form. So we have P is the statement, you have enough reward points. We're going to let Q be the statement, you have a free flight. So our argument in symbolic form will be, if P, then Q. That was our first premise. If you have enough reward points, you get a free flight. Our second premise was the negation of Q. You do not get a free flight. So our second premise is not Q. And our conclusion was, from our argument, was that you do not have enough reward points. So it's the negation of P. So our argument is in the form, if P, then Q, and not Q, therefore not P. So symbolically, that would be, in brackets, the conditional, if P, then Q, and not Q, and then the conditional, then not P. So therefore not P. So we need to check the validity of this argument. And I'm going to do that creating a truth table, because this doesn't fit the law of detachment. The law of detachment, we need the second premise to be P. The second premise is not P, it is not Q. So I need to create a truth table to see if this argument's valid. So I'm going to go to the next slide and I'm going to create a truth table. So the first thing that I am going to do in my truth table, step number 1, is to create the conditional if P, then Q. That's only false if the antecedent is true and the consequence false. So it's only false for case 2. Otherwise, it is true. All right, now I am going to create the not Q column. So I'm going to negate Q. So that's going to be false, true, false, true. Then I'm going to combine the two premises using the conjunction. So I'm going to do the and. And the and is only true if both statements are true. So it's only going to be true for case 4. Otherwise, it's going to be false. All right. So now I am going to create the negation of P. That is going to be my 4th step here. The negation of P would be false, false, true, true. And last but not least, I'm going to create the conditional between my conjunction here, column 3, and my negation of P, column 4. So the conditional will only be false if the antecedent is true and the consequent is false, which is not the case for any of these. For each case, the antecedent is either false, which makes the conditional true, or in the last case, case 4, the antecedent is true, but the consequent is also true. So for each one of these, we get a true logical value. So they're all true, is what I'm trying to say. So since our answer column is all true, this is a valid argument. Now we're going to populate the truth table. All right, let's continue. Let's look at this argument. We have determined if the following argument is valid or invalid. The grass is green, or the grass is full of weeds. The grass is not green. Therefore, the grass is full of weeds. So our first premise is going to be the grass is green, or the grass is full of weeds. Our second premise is going to be the grass is not green. And our conclusion is going to be the grass is full of weeds. So our first premise logically would be what? Well, we first need to create some statements here. So I'm going to create two statements, and I'm going to use the grass is green. So that's going to be statement P. And we're going to let statement Q be the grass is full of weeds. So my first premise is the grass is green or the grass is full of weeds. So this is a disjunction. The grass is green or the grass is full of weeds. So my first premise is P or Q. My second premise is the negation of the statement, the grass is green. So the grass is green is statement P. So the second premise is the negation of P. So it's not P. And my conclusion is the grass is full of weeds. So my conclusion is Q. So I need to create a truth table for this argument. And remember, the argument is going to be premise 1 and premise 2, then Q. So it's going to be if premise 1 and premise 2, then Q. And premise 1 is P or Q. And premise 2 is not P, then Q. So that is what we are going to create a truth table for. P or Q and not P, then Q. So we need to go and create a truth table. Okay, so we're going to create our 4 cases, PQ. True, true, false, false, true, false, true, false. Okay, so the first thing I'm going to do is I'm going to create the disjunction. So I'm going to do this right here. That's going to be my first column. So I'm going to do P or Q. And the disjunction is only false if both statements are false. So it's only false for case 4. Otherwise, it is true. Right? Then I'm going to do the negation of P. That's going to be the second thing I do. So we're going to negate P, false, false, true, true. And then the next thing I'm going to do is the conjunction. So that is going to be column 3. And the conjunction is true if both statements are true. Otherwise, it's false. So it's going to be false for the first case, the second case. It will be true for the third and false for the fourth. All right, so now I have the stuff inside brackets done. I'm going to repeat column Q. That is going to be my 4th column here. So I'm going to repeat true, false, true, false. And now we're going to do the conditional. And we're going to do the conditional between column 3, the conjunction, and column 4, which is statement Q. Okay, so the conditional is only false if the antecedent is true and the consequence false. Well, I have an antecedent that's true right here, but the consequent is also true, so it is true. Otherwise, it's true. So this is a valid argument. Since my answer column is all true, then the argument is valid. All right, so this leads us to a couple of laws of valid arguments. So we have four forms of a valid argument. And this actually is the law of syllogism, if you're interested. Okay, so here are our four standard forms of a valid argument. The first one is the law of detachment, which we saw from the very beginning of this section. So the first premise is if P, then Q. The second premise is P, our conclusion is Q. So if you have an argument that's in this form, it is valid. The second valid argument we have is the law of the contraposition. The law of the contraposition is in this form. The first premise is the conditional if P, then Q. The second premise is not Q. The conclusion is not P. So that is the law of the contrapositive. The next law is the law of syllogism. It is an argument that fits this form. The first premise is the conditional if P, then Q. The second premise is the conditional if Q, then R. The conclusion is if P, then R. The last argument we have, standard form that's valid, is the disjunctive syllogism. So the first premise will be the disjunction P or Q. The second premise will be the negation of P, so it will be not P, and our conclusion will be Q. So all four of these valid arguments are in your notes for chapter 3. The law of detachment, the law of the contrapositive, the law of syllogism, and the disjunctive syllogism. So you'll want to keep those notes available to you as you're working through this section's homework. So if you're looking at an argument and it fits one of these four forms, it is valid. Now, there are also standard forms of invalid arguments. So the first form of an invalid argument is the fallacy of the converse, which says, if my first premise is if P, then Q, my second premise is Q, my conclusion would be P. This is not a valid argument. So if you were to create the truth table for premise 1 and premise 2, then conclusion, you would not get true in the answer column. So this is not a valid argument. The second invalid argument form we have is the fallacy of the inverse. And this looks like this. The first premise is if P, then Q, the conditional. The second premise is the negation of P. The conclusion is the negation of Q. This is not a valid argument. If you were to create the truth table for this argument, the answer column would not all be true. So these are our two forms of invalid arguments. So we have 4 forms for valid arguments and 2 forms for invalid arguments. Okay, so you'll want to keep these notes handy as you're creating or you're doing the homework for section 3.5. Okay, so let's determine whether this argument is valid or not. Okay, so what are we going to do here? Get to the right part of my notes here. All right, so here's our argument. If you are on Instagram, then you see my pictures. So there's our first premise. Second premise is, if you see my pictures, then you know I have a dog. And my conclusion is, if you are on Instagram, then you know I have a dog. Is this a valid argument or not? So I first need to decide what my statements are going to be. And I have 3 here. The first statement I have is you are on Instagram. So that would be statement P. The second statement I have in the first premise is you see my pictures. So we would make that statement Q. Then in the second premise, I have another statement. That statement is, you know, I have a dog. So I have 3 statements in this argument. You are on Instagram. You see my pictures. You know I have a dog. And remember, what's a logical statement? A logical statement is a statement you can assign truth values to. So you can assign a truth value to you're on Instagram. You can assign a truth value to you see my pictures. You can assign a truth value to you know I have a dog. All right, so those are going to be our 3 statements, and then we're going to create our argument using symbols. Okay, so we're going to let P be you are on Instagram. Q, we're going to let that be you see my pictures. And R is going to be you know I have a dog. So I have 3 statements, P, Q, and R. So in symbolic form, my first premise was, if you are on Instagram, then you see my pictures. So this would be if P, then Q. The conditional. The second premise is, if you see my pictures, then you know I have a dog. So this would be if Q, then R. My conclusion is, if you are on Instagram, then you know I have a dog. So that would be if P, then R. If you're on Instagram, then you know I have a dog. So my argument would be, if P, then Q would be my first premise. My second premise would be if Q, then R. And my conclusion would be if P, then R. So is this a valid argument? Well, the first thing I'm going to do is I'm going to take my note sheet and I'm going to look at the 4 forms of a valid argument. Does it fit any of those 4 forms? And the answer is yes, it does. It fits the law of syllogism. The law of syllogism says the first premise is if P, then Q. The second premise is if Q, then R. The conclusion will be if P, then R. So since this does fit one of the 4 forms, it is a valid argument. So this is valid. All right, let's look at another one. Determine whether the following argument is valid or invalid. If it is snowing, oh, it is, isn't it? If it is snowing, then we put salt on the driveway. The second premise is we put salt on the driveway. So the conclusion is it is snowing. So I'm going to let my statements be P, it's snowing. I'm going to let Q be we put snow on the driveway. So those are going to be my 2 statements. So the first premise is in the form of the conditional, if P, then Q. My second statement is going to be just the statement Q, we put salt on the driveway. And my conclusion is going to be it's snowing, which is P. So we're going to let P be it is snowing. We're going to let Q be we put salt on the driveway. So our argument is if P, then Q. Q is our second premise. So our conclusion is P. So does this fit one of the forms of a valid or invalid argument? And this actually fits the form of an invalid argument. This fits the form of the fallacy of the converse. So this is a fallacy, which means it's an invalid argument. So since it fits one of those two forms of an invalid argument, then we can just say it's invalid. All right, let's look at another one. Same two statements. It's snowing and we put salt on the driveway. So this one's, the first premise says, if it's snowing, then we put salt on the driveway. So the first premise is the conditional, if P, then Q. The second premise is the negation of P, it's snowing. So the second premise, we say it's not snowing. So the conclusion here in this argument is that we do not put salt on the driveway. So we're going to have if P, then Q, using the same statements we used on the previous example. It's not snowing, not P. Therefore, we don't put salt on the driveway. So that is the argument we're looking at. Premise one, if P, then Q. Premise two, not P. Conclusion, not Q. Okay, so does this fit any of the forms that we have? Does it fit any of the four forms of a valid argument, or does it fit one of the forms of an invalid argument? And this is actually the fallacy of the inverse. So it fits one of the two forms of the invalid arguments. So since this is the fallacy of the inverse, it's a fallacy, which makes it an invalid argument. Okay, how about this one? If my cell phone company is Verizon, then I can call you free of charge. That's premise one. Oh my goodness, I got three premises here. Ooh. Premise two, I can call you free of charge, or I can send you a text message. That is two. Three, I can send you a text message, or my cell phone company is Verizon. That's premise three. My conclusion is my cell phone company is Verizon. So what do we have? We have three statements and three premises. The first statement will be that my cell phone company is Verizon. I'm going to make that my first statement. I'm going to call that P. And I have an if then. And I'm going to make my second statement, I can call you free of charge. I'm going to make that Q. So my first premise is if P, then Q. All right, let's look at the second premise. I can call you free of charge, which we already called that Q. And then I have, I can send you a text message. So we're going to let that be R. So I have my second premise, Q or R. So my first premise is if P, then Q. My second premise is Q or R. What's my third premise? I can send you a text message. Okay, that is R. Or disjunction, my cell phone company is Verizon. So that is P. And my conclusion is going to be my cell phone company is Verizon. So that's going to be P. So my first premise is if P, then Q. My second premise is Q or R. My third premise is R or P. My conclusion is P. So I have to create a truth table for this. because I don't think that I have an argument, any of those that have 3 premises. So I'm going to have to create a truth table for this. So I'm going to let P be my cell phone company is Verizon. Q be I can call you free of charge. And R, I'm going to let that be I can send you a text message. So my premises in symbolic form would be if P, then Q, Q or R or P, my conclusion is P. So I'm going to have to create a truth table for combine the 3 premises using conjunctions. And then I'm going to, that combination, we're going to use that as the antecedent for conditional. So the argument we're going to test is first premise and second premise and third premise. That's the antecedent, the entire thing. Can I spell that? And the P is going to be our consequent. Okay, so we got quite a bit of work to do, but it's one step at a time, and you know how to create truth tables. So I'm going to first create the conditional if P then Q. I'm going to create the conditional, not the conditional, the disjunction Q or R. I'm going to create the disjunction R or P, and then combine those using conjunctions. Once I have that conjunction, then I'm going to use that as the antecedent for my conditional. All right, so here we go. So I have 3 statements, so I'm going to have 8 cases. P can be true, 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 false, 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 false. Q can be true, true, false, false, true, true, false, false. R can be true, false, true, false, true, false, true, false. Okay, so the first thing I'm going to do is create the conditional, which is the first premise. So the first premise was if P, then Q. The conditional is only false if the antecedent is true and the consequent is false. So it will only be false in case 3 and case 4. In case 3 and case 4, P is true and Q is false. All right, so I have that conditional. So the next thing I'm going to do is I'm going to create the second premise, which is the disjunction. So in column 2, label 2 down there, I'm going to create Q or R. Q or R will only be false if both of those are false, if both Q and R are false. So it's going to be false in case 4, and it's going to be false in case 8. Otherwise, it is true. All right, so now I'm going to combine the first 2 premises using the conjunction. So I'm going to combine those using an and. So I'm going to combine column 1 and column 2 using a conjunction. The conjunction is only true if both statements are true. So in this case, it will be true in the first case, the second case. It will also be true in the 5th case, the 6th case, and the 7th case. In the 8th case, it's false. So the column that's highlighted in red is the combination of premise 1 and premise 2 using the conjunction. All right, now I'm going to move to premise 3, which is going to be column 4. The third premise was R or P. The disjunction is only false if both statements are false. So R or P will only be false when both R and P are false. So it will be false for case 6 and in case 8. Otherwise, it's true. All right, so now we're going to combine all 3 premises. So we're going to combine those using the conjunction, and we're going to combine column 3 and column 4. And that's going to be column 5. So we're going to take column 3, we're going to take column 4, and we're going to combine those using the conjunction. So the conjunction is only true if both statements are true. So it would be true for case 1, case 2, it will be false for 3, false for 4, true for 5, false for 6, true for 7, and false for 8. So that is the combination of all our premises. So this is all of our premises. So now we have to look at the conditional from combining all of our premises using a conjunction to the conclusion, which in our case was P. So we're going to have if column 5, then column 6. So we're going to combine column 5 and column 6 using the conditional. And the conditional is only false if the antecedent is true and the consequent is false. So we have true, true, so it'll be true. True, true, so it'll be true. False, true, that'll be true. False, true, that'll be true. True, false, it will be false. So we're done. This is not a valid argument because if any of these values is false, it is not valid. And we can continue to look. We have false, false, that would be true. True, false, oh, that would be false also. And then false, false would be true. So because we have those two falses in our answer column, this is not a valid argument. That's a lot of work to tell you that it's not a valid argument, but it is not a valid argument. All the answer column must be true for this to be valid. So the answer column, column 7, is not true in every case. Thus, the argument is a fallacy or invalid. Okay. Now, the last thing we're going to do today is look at how we can draw a conclusion when we're given a set of premises using one of our valid arguments, one of the 4 forms of a valid argument. So we have here an example where we're going to create a conclusion. So what do we have here? We have the statement, if the camel is a dromedary, then the camel has 1 hump. The camel does not have 1 hump. Therefore, what's our conclusion? So our 2 statements are going to be, statement P is going to be, the camel is a dromedary. And statement 2 would be that the camel has 1 hump. Those are the 2 statements we have in this example that we can assign a truth value to. So our first premise would be that the camel is a dromedary. Then the camel has 1 hump. So it would be the conditional if P then Q. The second premise is that the camel does not have 1 hump. So it's the negation of statement Q. So our argument is if P then Q, not Q. So what's our conclusion? So if we go to our set of arguments, we have a valid argument called the law of the contrapositive. Which fits these first two premises. If P then Q is premise 1, not Q is premise 2. And our conclusion then is not P. That is the law of the contrapositive. So we need a not P as our conclusion. So what's our conclusion? Well, what's the negation of P? If P is the camel is a dromedary, then not P would be the camel is not a dromedary. So our conclusion would be from our premises, if the camel is a dromedary, then the camel has 1 hump. The camel does not have 1 hump. Therefore, the camel's not a dromedary. which I didn't write that very neatly. And that is the end of section 3.5, which means we have completed this chapter. So since we have completed the chapter, that means you have an exam that's coming due. And that exam will be due a week from today. A week from today, I believe, is March the 2nd. So you will have an exam due March the 2nd at 5 p.m. Are there any questions about that? Any questions at all? All right, well, if there aren't any questions, I'm going to conclude the recording and I am going to end the meeting. And we will hopefully see you on Monday.